In this sublesson, we'll see how to configure and verify VXLAN with flood and learn mechanism. For the demonstration purpose, we'll be using this topology. We have 2 spine switches and 3 leaf switches which are connected to the host. In this topology, most of the devices are pre-configured except for leaf 1. We'll be configuring leaf 1 and then we'll be looking at the VXLAN fabric to understand and verify the data forwarding. On leaf 1, let's first verify if we have the reachability to the spine nodes as well as the other leaf nodes. So show IP route OSPF, and we can see we have the reachability to the spine, which is having the IP 11.11.11.11, and the second spine, which is 12.12.12.12. This is the Anycast RP address that is configured on the spines. We'll look at the configuration in a bit. And this is the leaf 2, and this is our leaf 5. So we have the reachability to all the leaves and the spine nodes in the fabric. Now let's look at the multicast configuration before we jump on to VXLAN configuration. So show run PIM, and under the PIM configuration we have our static RP configuration already present. We have our interfaces part of the multicast sparse mode. So we are having our multicast configuration already in place. Let's verify the information on spine switches. So let's look at show run PIM, and we can see we have the RP address defined. The address 111.111.111.111 is configured under the interface show run interface loopback 0, and this is our secondary IP address. The secondary IP address is same on both spine 1 and spine 2 to make sure we have an Anycast RP. The Anycast RP is then configured using the command IPPIM Anycast RP, the RP address of the fabric, and who is going to be the IP that holds this address. So it's going to be 11.11.11.11 and 12.12.12.12. And rest, apart from that, we have all the interfaces part of the PIM sparse mode. Now that we have verified the PIM configuration, the next step is we configure the features that are required to configure the VXLAN segment and the overlay interface. So we go into the config mode and say feature NV overlay, which is required for configuring the overlay interface. And the second feature we need is feature VN segment VLAN based. This feature is required to configure VLANs with and associating them with the VN segment IDs. So we have configured this feature as well. We do not need other features like BGP because we are not using that. The other features that are required to be configured on the spine or leaf is the feature PIM and OSPF, which is already pre-configured. So now we'll see how to configure the VN segment under the VLAN. So we'll define a VLAN 1501, and say VN segment 10501. And then we have VLAN segment 1502 and VN segment 10502. Make sure this VN segment configuration and VLAN to VN segment mapping is same across all the leaves. So on leaf 2, we look at show run VLAN 1501, 1502, and we can see that they have the correct mapping. Similarly, we can go ahead and check the information on leaf 5, and let's verify the information on leaf 5, and we have the leaf 5 configured with the same VLAN to VN segment mapping. So that is good. Now let's configure the overlay interface. So we say interface NVE1, and under the interface the first thing we configure is the source interface, which is going to be loopback 1. So if you look at the show IP interface brief, we can see the loopback 0 is being used for our router IDs, say for OSPF, and loopback 1 is the IP on this interface is going to be used as our VTEP IP. So we have configured source interface as loopback 1, and then we'll configure the L2VNI mappings. So we have member VNI 10501, and we'll have the mapping as mcast group 231.1. Let me verify the multicast address. Show run NV overlay 231.1.150.1. So 10.150.1, and remember VNI 10502, we have .2. So we are using different multicast addresses for both the VNIs. You can use the same multicast address as well, but having different multicast addresses helps with troubleshooting the VXLAN fabric. So we have configured both the layer 2 VNIs. We'll now perform a no-shut. Now we have performed a no-shut. Now let's verify the information. At this point, the fabric should not have identified the other VTEPs. The leaf1 will not know about any of its other VTEPs that are configured. So if I do show NVE peers, we do not have any entry. Let's first look at the NVE interface. So show NVE interface, and we can see the information. The first thing is the state is up for the NVE interface. Encapsulation is VXLAN. This is the local system MAC or the router MAC. The host learning mode is data plane. Remember when I mentioned that the flood and learn mechanism or ingress replication on its own is the data plane learning mechanism, because only when we send traffic from the host, that's when we learn about the remote VTEPs. The source interface is our primary IP, loopback 1 interface IP, 192.168.1.1. Similar information should be present on leaf 2. So show NV int, and we can see it is 192.168.2.2. And on leaf 5, show NV int, and we can see 192.168.5.5. They are all data plane learning mechanisms that are configured, and that's what we are using. So now let's initiate traffic from the host. So on this host, we are going to say ping 10.150.1.5. And this is the host connected to leaf 5. And we can see that we have the successful traffic going across. But if you look at the leaf, we should now have learned about the remote leaves. Show NV peers. This NV peer is for the reply that we received from the host 5 attached to leaf 5. If I look at the information on leaf 2, we can see show NV peers. We'll only see the information about leaf 1. Why? Because we have received the multicast bump traffic from leaf 1 host. And that's why leaf 2, even though there is no communication happening between leaf 1 and leaf 2 at the moment, leaf 2 has the information about leaf 1. Leaf 5 should now also have the information about leaf 1 because we have received the multicast packet or the data traffic from the host connected to leaf 1. So we have the information populated here, and leaf 5 information is populated on leaf 1. Now, unless we send traffic to leaf 2, we are not going to see any NV peer information about leaf 2. So now, unless we initiate a traffic from host 1 towards host 2, host 1 is not going to learn about leaf 2, or leaf 1 is not going to learn about leaf 2. So we'll say ping 10.150.1.2, and we can see the traffic flowing. And if we now move to leaf 1 and run the command show NV peers, we can see we have now 2 NV peers, leaf 2 and leaf 5. On leaf 2, we should only be seeing leaf 1 as the NV peer. This is how we can configure and verify the information for VXLAN in a flood and learn environment on Nexus 9000 switches.